I give you the example and also describe the method for finding the orthogonal trajectory. For example, we're given here a function given the family of curves, given family of curves. The family of curve is f, x, y, c, and 0. We want to find the orthogonal trajectory for the given family of curve. So step 1 is we find the slope. We find dy by dx and simplify this one so that we can get the function of xy. We already discussed in chapter 1, so to find the equation for the given equations. So this is here is tangent. We say this is a tangent to the curve, at any point xy. So once we get this tangent, then number 2, we write here differential equation of orthogonal trajectories. So that's will be my very important to note. Dy by dx is equal to minus 1 over fxy. We check here in the example we have already done. What we find? We find dy by dx is equal to fxy. Now what's my fxy? My fxy was equal to y upon x. Then differential equation for the orthogonal trajectory, which was the circles, what is that? The differential equation was dy by dx was minus x upon y. What's minus x upon y? Minus x upon y, we can write here this equal to minus 1 over y upon x. I would say this is minus 1 upon fxy. So if we write here minus 1 upon fxy, this is dy by dx minus x over y. This means when we're having this equation and we solve it, we'll get here, for solving this equation, we get here this curve, and this curve is orthogonal trajectory. So we get here negative reciprocal of the function. Here we say, and then number 3, we solve this one, and the solution of the differential equation here is g xy and c1 equal to 0 is the family of orthogonal trajectories, orthogonal trajectory. So it's very easy. Just we have to find the differential equation and then to solve it. We find the tangent to the curve, then we write the differential equation. There is 1 upon xy, we get this xy, and we apply it and we get the solution. I explain you with the help of example. We take an example and we given the family of curves given to us, and we solve this one to find the orthogonal trajectory for the function. So the example is find the orthogonal trajectories of the family of curves given by the equation C1 x square minus y square equal to 1. We use our method. Here we want to find the differential equation, we find the derivative with respect to x. So derivative with respect to x, I get here C1, I get here 2x minus 2y dy by dx is equal to 0. Derivative of this one, we use implicit differentiation, and that helps us to find the derivative. Now we simplify this one. We'll get here this taking to the other side, we get here 2y dy by dx is equal to 2c1x. So what's my dy by dx? My dy by dx is equal to divided by 2y. So 2 is considered 2, we get here c1 x over y. So I find the value of c1 because I must get here the function of xy. So I have to eliminate c1. So I can get here my c1 from here. I have c1 x square is equal to 1 plus y square, and my C1 is equal to 1 plus y square over x square. So I put the value of C1, I get here dy by dx is equal to, C1 is 1 plus y square over x square multiplied by x over y. We simplify this one, we get here 1 plus y square over xy. So I write here my dy by dx is equal to 1 plus y square over xy, and this is actually my function fxy is equal to 1 plus y square over xy. This is my step 1. This here is my step 1. I find dy by dx, and we find this tangent to the curve at any point. We identify the function fxy. Now we write number 2. We write here differential equation for the orthogonal trajectory. This is number 2. We write here differential equation of orthogonal trajectory of orthogonal trajectory. This is very important step, and we must do it carefully. We get here dy by dx is equal to minus 1 over f of x y. That's here dy by dx. I have identified my fxy is 1 over, I get here 1 plus y square over xy. I'll get here dy by dx is equal to minus xy over 1 plus y square. So this is my differential equation, and this differential equation I need to solve this one to find the equation of the orthogonal. I get the differential equation of orthogonal trajectory. So this is my step 3 that I want to solve it. So here I have this my step 3. I want to solve the differential equation dy by dx is equal to minus x into y or 1 plus y square. So this is a separable variable equation. I keep the x on the right hand side and I take my y on the left hand side. I'll get here 1 plus y square over y into dy is equal to minus x dx. We have a variable separable form. We integrate it. We can get here this is 1 over y plus y into dy is equal to integral minus x dx. We integrate it. We get here ln of y. I have ln of y plus y square by 2 is equal to minus x square by 2 plus constant c1. So I can rewrite this one. I can write to take x square plus y to the right hand side. I get here ln of y plus y square by 2 plus x square by 2 is equal to c1, and this is my equation of the orthogonal trajectory. So my equation of the family of curve of orthogonal trajectory is this equation ln of y plus 1 by 2 x square plus y square is equal to c1. So this is the solution of my problem. We have the family of curves. I find the differential equation, identify fxy, then write the differential equation. That's very important step. We write the differential equation of the orthogonal trajectory. That's here we have to mark this is minus 1 over fxy. So then we have to solve the differential equation, and that will give you the family of the curve for the orthogonal trajectory. I took this example. Find the orthogonal trajectory of the family of curves c1x square minus y square equal 1. This is my equation. First, I have to find the tangent to the curve. I find the implicit differentiation. Derivative of x square is 2x. Derivative of y square is 2y dy. Therefore, 1 is 0. I solve this one to get dy by dx. So dy by dx is minus c1 x over y. I want to eliminate c1. So I take this one here, and we find the value of c1 from this. We take y square to the other side, 1 plus y square divided by x square. Substitute the value of c1 here, then x is cancelled with x square. We get here x. We get 1 plus y square xy. So this is my differential equation. And from this differential equation, I can say this is my fxy that I want to identify. This is my step 1 to identify my fxy. Once I identify xy, I can write the differential equation. So I say my differential equation for the orthogonal trajectory is dy by dx is equal to minus 1 over fxy. Fxy is 1 plus y square xy. If we take the reciprocal, we get minus xy or 1 plus y square. This is my differential equation of the orthogonal trajectory. I want to solve this one. So we can see here that because you can separate x and y, so this means variable separable. We take y to the left and x to the right. We get 1 plus y square over y. They will change. This numerator become denominator and denominator become numerator and numerator become denominator minus x. Then we just integrate this one, divide by y. We get 1 over y plus y dy. Integrating it, we get ln of y square by 2, x square by 2, take x square by 2 this side. So this equation is my g x y c1 equal to 0. This is my family of curve for the orthogonal trajectory. So these two trajectories, family of curve, this one and this one, when we plot this one, then they are going to intersect orthogonally. Their tangents are orthogonal to each other.